Good morning, dear cadets. So we are in the KMnO4 potassium permanganate, especially their oxidizing character. So oxidizing character in acidic medium I have completed. Now yesterday only I have started oxidizing character of KMnO4 in neutral medium or weakly alkaline medium. So yesterday only I explained you that new oxidizing character in neutral medium and alkaline medium is almost similar. Okay. So now so many reactions also I taught you, isn't it? Like oxidation of sodium thiosulfate, H2O3 negative ion, isn't it? Sulfate is the product. Okay. So yesterday we have discussed so many things. One character was left, not character, actually one salt was less. Means oxidation of Mn2 positive salt in neutral medium or weakly alkaline medium by KMnO4. Okay. So that reaction I wrote here. Just try to understand. First step is same for all, just like a acidic medium. So KMnO4 H2O, this is neutral medium or alkaline medium. So it is very easy for remembering a thing. In acidic medium here H2SO4 would be there, but because that is the oxidizing character of KMnO4 in acidic medium. Here what is there? Oxidizing character of KMnO4 in neutral medium or weakly alkaline. Faint, in NCERT book they have used word faintly alkaline. That is the meaning of weakly alkaline only. Okay. And in one heading only they have written 3-4 reactions. I am going through the NCERT book also. Don't worry. I am not teaching extra also. So just try to understand. KMnO4 H2O, product is KOH, MnO2 and 3O. That is common for all. Second step, I have to take here one salt of manganese, where the oxidation state of manganese is 2 positive. So Mn2 positive means MnSO4 I took. Now H2O and that nascent oxygen which has come out in the step number first will be used here. So MnSO4 means Mn2 positive will be oxidized into MnO2 H2SO4. Now to cancel out this one we have to multiply with 3, because here 3 oxygen is there, so second reaction should be multiplied with 3. Now here also it is very easy to remember. In case of K2Cr2O7 you have in case of KMnO4 reaction in acidic medium you have multiplied with 5. Here you are multiplying with 3, because 3 nascent oxygen has evolved. Now there is one problem here, especially in case of sodium thiosulfate. Here H2SO4 is formed and KOH is here also. So this is base and this is acid. So third step should also be written. What is the need of third step? We have to neutralize alkali and means acid and base we have to neutralize. So second reaction is nothing to do with the oxidizing and reduction character. It is related with the neutralization reaction. Okay. Now just see, add all the 3 steps. So now 2 KMnO4, 3 MnSO4, H2SO4 has been cancelled out. Now 2 KOH is completely cancelled out. Now water, just see, 3 water and 1 water. So total 4 water molecules is there. But here in the product side 2 is there. So out of 4, 2 will be cancelled out, 2 is left here in reactant side. Now next one is 5 MnO2. Why 5 MnO2? 2 MnO2 plus 3 MnO2. So total 5 MnO2. Then K2SO4 plus what is there? H2SO4. Just see. Here 1 H2SO4, here 3 H2SO4. So 1 will be cancelled out, 2 H2SO4 is left. Now R part. Now you have to write the ionic form. So here just see, spectator ion cancelled out. Okay. So 2K is cancelled out. Now 3SO4 is cancelled out. What is left? Now writing ionic form is very easy. Just see. Here see, 2 MnO4 single negative, 3 Mn2 positive plus 2 H2O, 5 MnO2 plus 4 H positive. This is ionic form of reaction. Now here what is the oxidation state of Mn? Plus 7. But what is the oxidation state of this one? Plus 4. So plus 7 to plus 4. What is this one? This is reduction. Hence it is oxidizing agent. So in KMnO4 in neutral medium, Mn is oxidizing into reduced into Mn4 positive. Now Mn2 positive, just see, Mn2 positive is here oxidizing into 4 positive. So this is undergoing oxidation. So now this is one type of disproportionation reaction also, because the same substance, that is Mn, is undergoing oxidation and reduction. Just you can check, correct? Mn here +7 to +4, Mn2 positive to +4. So here MnSO4 is undergoing oxidation, hence it is a reducing agent, and MnO4, KMnO4 is undergoing reduction, hence it is a oxidizing agent. So in this way this is completely completed. Okay, all reactions I have covered. Now practice it. Now I will tell you in which form or how the question will asked in the exam. There is one more issue that should be discussed here only. In acidic medium of KMnO4, how many electrons are added? In ion electron method, that you can only do when you know the balancing of redox reaction by ion electron method. And last year, time and again, almost every video I am telling you that last year I had taught. Okay, so now this reaction you can split into two half cell, oxidation half cell and reduction half cell, and keep balancing. Suppose same reaction is taking place in acidic medium, then 5 electron you have to add. Okay, in neutral medium 3 electron. Okay, little bit difference is there between acidic medium and neutral medium. In basic medium only 1 electron has to be added, 1 electron towards the KMnO4 or MnO4 single negative side. Now just see the electrode potential of KMnO4 is in acidic medium is plus 1.52 volt. In neutral medium this is 1.69 volt. In basic medium this is 0.56 volt. Okay, what is this one? This is electrode potential value. And last year you learnt one thing. If electrode potential value is positive, so the given reaction is feasible in given direction. Given reaction, if electrode potential value is positive, then given reaction is feasible in given direction. Correct or not? Last year we have studied, and this is given in your NCERT book also. So according to the electrode, now where this reaction should be more, means oxidizing character of KMnO4 should be more feasible in neutral medium. It should have been more feasible. Okay, I wrote here. Observation, just see, greater the positive electrode potential, greater will be the feasibility of reaction in given direction. Hence, oxidizing character of KMnO4 in neutral medium should be highest. This is observation. But what is the actual practice? But just see, actually the oxidizing character of KMnO4 in acidic medium, it is very high. Why? Just see, even yield rate is also very high and yield is also very high. Okay, what is the reason? Just see, if you see the reactions, so just see, in acidic medium, near about 8H positive is present, but it is highest in acidic medium due to presence of H positive ion and Mn2 positive ion in acidic medium. This is Mn2 positive ion in acidic medium. Please, clarity may not be there, but I am just telling. I wrote here Mn2 positive ion in acidic medium. Okay, so in acidic medium, why the rate of reaction is very high and yield is very high? It is very simple thing, just try to understand. In acidic medium only Mn2 positive ion is present. Rest everywhere Mn2 positive ion is not present. Means in the product of KMnO4 in neutral medium, the product of KMnO4 in basic medium, MnO2 is the product. Mn2 positive is not the product. Okay, so just try to understand. H positive, their electrode potential is 0.0 volt. Correct? And water electrode potential is minus 1.23 volt. Okay, so the positive electrode potential means H positive should have been oxidized the water, because in neutral medium, in basic medium, water is the product. Water is not here product, just you can see, but in acidic medium water is the product. Water is the product or not? Then what should be there? What should be there? Water should have been, water electrode potential is a negative, minus 1.23 volt. Then what should have been? It should oxidize by H positive. Correct or not? Just see the electrode potential. So what I was telling, I was telling here, in neutral medium, its electrode potential is 1.69 volt and water electrode potential is H2O. So just see, it is minus 1.3 volt, okay, 1.23 volt, okay. So this is a negative electrode potential, okay, correct or not? So what I was telling you, in acidic medium, what should be there? What should be there? KMnO4 should oxidize water. Should oxidize water or not? Why? Because in acidic medium, KMnO4 electrode potential is plus 1.52. Or in neutral medium, in neutral medium, its electrode potential is 1.69. But what is there? It is not oxidizing. Actually, it should have been oxidized. Why? Because in neutral medium, Mn2 positive towards the product side is not formed. In acidic medium, Mn2 positive is formed. Mn2 positive is formed in the product side. You can check the acidic medium reaction. So Mn2 positive, I told you, it is acting as a autocatalyst. What is that one? Mn2 positive is acting as a autocatalyst. So automatically it initially reaction would be slow, but after some time the rate of reaction would be increased. So the conclusion of this discussion is, alone electrode potential is not a criterion to decide the rate of reaction. What is there? Chemical kinetics is also one of the better to say like that. Electrode potential is not only the criterion to check the feasibility of the reaction. To check the feasibility means a possibility of occurrence of that reaction in the given direction. So what I want to say here, what is the ultimate conclusion here? Electrode potential is not only criterion to check the feasibility of reaction. Chemical kinetics is also one of the important criterion to check the feasibility of the reaction, because according to electrode potential, now what should be there? In neutral medium, KMnO4 oxidizing character should be highest and yield should be more. But in actual practice, the yield of product is more and rate of reaction is also more in acidic medium. Why? Because what is there? Mn2 positive which is formed there, that is encouraging or motivating the permanganate ion MnO4 single negative ion to oxidize the water. So that is why rate of reaction is more. Correct? This is there. So please you can write. So here I wrote chemical kinetics is deciding the rate of reaction also. That word should be there. In this way your KMnO4 is completely completed. Now we'll tell you some questions, okay, and we'll tell you how to solve them, and that type of question will come definitely. Just see here, I have written here 4 equation, okay. In the exam they will ask like that. So I will start with the 4th one, means 4th, 3rd, 2nd and 1st. Just see. Even though they are 4, but they are having different nature. Just see, last means 3rd and 4th, they are balanced. Just see, reactant side they are balanced. So if they are balanced, it is very easy to write the product. But if they are imbalanced, then you have to write 2-step reaction which I taught you in case of K2Cr2O7 and KMnO4. Okay, then only you will come to know what would be the stoichiometric coefficient. Okay, now just see here, this is MnO4. Now 16H positive indicates that reaction is taking place in acidic medium. Okay, now last year ion electron method I taught you. So this reaction is taking place in acidic medium. What is this one? C2O4 oxalate ion. Now how many carbon atom is here? 10. So just see, In oxalate, the oxidation state of carbon is 3. Now what would be one product? One product would be CO2. Now how many CO2? 10 CO2, because carbon is here 5 to the 10. Okay, over. In acidic medium, Mn here, oxidation state of this Mn is +7. Now this is oxidizing agent, so this must be reduced. So in acidic medium, the reduction product of KMnO4 is Mn2 positive. So write down here Mn2 positive. Okay, now just see how many Mn should be there. 2 are here, so write down here 2 Mn plus what is the another product? Now just see here, number of oxygen is both side. If you see 4 into 5, 24 oxygen is here, 24 oxygen, and number of hydrogen is 16. So if we will write here 8H2O, so hydrogen is balanced and oxygen is also balanced. You can check 10 into 2, 28, 18 oxygen, sorry 28 oxygen, and 28 oxygen is there, 4 to the 8 and 5 into 4, 20, it is balanced. So now in this way only you will get questions in exam, like that only. Reactant they will give you, product you have to write. Another one, just see this one. Now here what is the oxidation state of chromium? Chromium oxidation state is +6, and you know K2Cr2O7 or Cr2O7 is the oxidizing agent. It must undergo reduction. So what is the reduction product of Cr6 positive? Cr3 positive. Cr3 positive. How many chromium is here? 2 chromium. So write down here 2 chromium. That is the reduction product. What is the now? Cr2O7 is the oxidizing agent. That is why it is undergoing reduction. Fe2 positive, that is the reducing agent. So it must undergo oxidation. So what is the oxidation product of Fe2 positive? Fe3 positive. Fe3 positive. How many Fe2 positive is there? 6. So write here 6 Fe3 positive. Now this reaction is also taking place in acidic medium. So plus here how many H positive is there? 14. So here what is there? 7H2O. 7H2O. Now check, reaction is balanced. Now these two are bit different. Why? Because they are not balanced. Okay, so we'll balance it, don't worry. Start with here Cr2O7, 2 negative. This is also taking place in acidic medium. So one product is Cr3 positive. Cr3 positive. Okay, here write 2, no problem. Another one is Sn2 positive. This is oxidizing agent, so it is undergoing reduction. Sn2 positive is reducing agent, so it must undergo oxidation. So what is the oxidation product of this one? Sn2 positive? Sn4 positive. So Sn4 positive. Now H2O must be there. H2O must be there. Now what should be the number here? Okay, then what is there? You should write 2-step reaction. Taking K2Cr2O7, you should work out. So now after working out, you will come to know what should be the stoichiometric coefficient here. That is why I wrote and I explained full reaction, so that you can write the correct product. Okay, correct product. Now here I will balance, there is no problem. Very easily you can write the things. Cr2O7, Sn2 positive. So the product is 3SN4, here 7H2O, 3SN4, here 3SN2 positive. Now here 14H positive. 14, you can remember also, just see in almost every reaction of K2Cr2O7 in acidic medium, now H positive was 14 only, correct? Now same is the case with here. Now this is also in acidic medium, so one product here will be the water, H2O. Now Fe2 positive will be oxidized into Fe3 positive. Now MnO4 in acidic medium reduced into Mn2 positive. Now balance the reaction. Balancing, just see in acidic medium of KMnO4, just see how many water molecules are added. 8H positive. 8H positive. So 8H positive means you have to write here 4H2O. 4H2O. 5Fe 2 positive, 5Fe2 positive. Now 4 to the 8 H2O. Number of oxygen is balanced. Now don't worry, suppose you are getting difficulty in the balancing. So do one thing, write down in the rough sheet 2 steps reaction. Now take 1 salt of Fe2 positive, work out and come to the conclusion of final ionic form of reaction. You will write that one. But preliminary knowledge you should have. The oxidation product of Fe2 positive is Fe3 positive. Suppose still you are not able to do all those things, then what is there, that much you can write. The oxidation product of Sn2 positive is Sn4 positive. Oxidation product of Fe2 positive is Fe3 positive. Okay. Same is the oxidation product of oxalate ion is carbon dioxide. So final, let it not be balanced, but final product correctly you can write in very easy way. Okay. If you will write the correct product but balancing is not there, then also you will get some marks. So like that. Now such kind of reaction is also there. Complete the following reaction. So you know this is the heating effect of KMnO4. Heating effect on KMnO4. So what is the product here? K2MnO4. K2MnO4. That is the only product. Any other product here? Yes, 2KMnO2 plus O2. MnO2 plus O2. You have to remember here. Write down here 2. Now in this case, what is the product? One product is this one only, K2MnO4. K2MnO4 plus 2H2O plus 2H2O. What is K2MnO4? This is KMnO4 is potassium permanganate. K2MnO4 is potassium manganate. Okay. Here oxidation state is +7. Here +6. Okay. Everything I have completed as far as K2Cr2O7 and KMnO4 is there. Okay. Now there are so many questions like that only in the NCERT book also and some other book also. Please practice. You will get like that only. You have to write the final product. Incomplete reaction is there, you have to complete that one. And almost every year 2 reactions they are asking. That is of 2 marks only. Now you will tell, sir, marks is only 2 and you taught so many reactions. Even I don't know which reaction will come. But for every reaction rules I told you. So forget about the balancing. But final product you should write correctly only. Very easily you will get. Now while solving all those things, if you will follow the 2-step reaction, then you will come to know each and everything. In NCERT book what they did, they wrote only in ionic form only. Ionic form only. They follow only ionic reactions only. But how those ions have come, they have not explained. That is why I took 2, 3, 4 periods and completely completed. Almost every year questions are coming from that part. So now let us move toward the last part of this unit, that is lanthanides and actinides. So now I am starting here lanthanides and actinides. So as you know, they are known as F block elements. Okay. So first start with their position in the periodic table. So they have been placed below the 2 horizontal line in modern periodic table. Below the periodic table in 2 horizontal line in modern periodic table. Okay. Below the main body of the periodic table. The question arises here, why they have not been included in the main body of the periodic table? They have not been included in the main body of the periodic table because continuity and periodicity of the periodic table would have been disturbed. That is why the periodicity means occurrence of similar property element. They have got a lot of variation. Continuity is not there in their property. That is why they have not given in, means they have not been included in the main body of the periodic table. Elements which are given place in the main body of the periodic table, there is a regular trends in change in their properties. Here regular trends is not there, that is why. Okay, they are called as F block element because their last electron enters in F orbital or F subcell. Okay, their general electronic configuration is n-2 F 1 to 14, n-1 D 0 to 10, and ns2. Okay, last electron enters in anti-penultimate cell. Anti-penultimate cell. Now already I taught you the meaning of anti-penultimate cell. Last but two. Okay, n-2 F subcell. In case of transition element, what was there? Last but one cell, that is the n-1 D subcell. Okay, here I made again, this is the nucleus, this is cell number 1, 2, 3. So now just see, outermost cell is NS cell. Last but one cell means second cell, n-1 D subcell. Now this is from outside, this is third cell. So n-2 F subcell. So this is known as anti-penultimate cell. Last one is the outermost cell, second one is the penultimate cell, third one is the anti-penultimate cell. Okay, there are some more points regarding this one. Lanthanides are known as 4F series, actinides are known as 5F series. We'll write all those things. They are known as inner transition elements. They are also known as heavy earth metals. Okay, so we'll justify those words. There are some more points regarding the lanthanides and actinides. So just try to understand, as transition elements have been divided into 4 transition series. Transition series first, second, third and fourth. Similarly, F block elements, they are also divided into 2 categories. One is lanthanides, that is also known as 4F series. Another one is actinides, that is 5F series. And combinedly they are known as F block element. F block elements. Okay, now just see, lanthanides and actinides are commonly known as inner transition elements. So when I was teaching you transition series, that time only I taught you why they are known as inner transition elements, because they are found inside of the third and fourth transition series. Just see, third transition series starts from lanthanum 57 and goes up to Hg80, but after 57 there is a gap of 14 elements. How many elements? 14 elements. Okay, starting from cerium 58 to lutetium 71. Lutetium 71. These elements only, cerium 58 to lutetium 71, they are only lanthanides, and they are, means their last electron will enters in 4F, that is why they are known as 4F series. Now actinoids, they are found inside of the fourth transition series. Which one? Fourth transition series. Just see, starts from fourth transition series, starts from actinium 89, but after 89, right from thorium 92, lawrencium 103, lawrencium 103, there is again gap of 14 elements. These 14 elements are only known as actinoids, and their last electron enters in 5F, that is why they are known as 5F series. Okay, so we have to discuss here lanthanides and actinides only, because transition series we have already discussed. So there is one more name of lanthanides and actinides. Lanthanoids and actinoids are known as rare earth heavy metal. Rare earth heavy metal. Why? Just see, number one is their atomic size is large, that is why they are heavy metal, and their presence on the earth is rare, that is why they are known as rare earth heavy metals. Okay, so now this is the introductory point about the lanthanides and actinides. Now as we have discussed the trends in physical property of transition elements, in the same way we should discuss the trends in physical property of these elements. Okay, so we'll begin with the electronic configuration. We'll begin with the electronic configuration. Now remember here, these are only 90 thorium to lawrencium 103, they are only actinides. and here cerium 58 to lutetium Lu71, they are lanthanides, and this one HF72 to Hg80, that is the third transition series. Similarly here Rutherfordium 104 to Unbium 112, that is fourth transition series. Fourth transition series is incomplete. So now let us have more idea about the electronic configuration. 1-2 things about the electronic configuration. Just see, there is a lot of controversy as far as the electronic configuration of lanthanides and actinides is concerned. Now here I am following the electronic configuration of NCERT book which they have given. Okay, so there is a common consensus on the electronic configuration of lanthanides and actinides. That common consensus only I will write on the blackboard. Okay, now in some book little bit difference is also there. Even in the modern ABC and NCERT book little bit differences are there. Nevertheless, I will write the combined view, means consensus view on electronic configuration by the scientist. That only I will write. You should also follow same electronic configuration. So dear cadets, this is the electronic configuration of lanthanides. Okay, just try to understand. Of course I wrote the electronic configuration of lanthanum also, but this is not a member. Only 14 members are considered to be the lanthanides. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. You see the electronic configuration. In lanthanum 4f0 electron is there, 5d1 electron is there, and 6s2 electron is there. And now just see, after lanthanum, cerium is the first member of lanthanide series. Okay, so just see, it is not having one electron. 4f is not having one electron because 5d1 electron shifted to the 4f. That is why what is there? One 4f electron by cerium and another one second electron of this one f block has come from 5d. In all the cases you can see 5d is 0 only. So this is 4f2. Now this is cerium, this is praseodymium 4f3, 5d0, 6s2. This is neodymium 60, 4f3. This is promethium 4f5. This is samaracium 4f6, 5d0. Now this is europium. If I am not wrong, let me check. This is yes, europium only. Europium. So 4f7. Now this is f orbital is half filled now. Okay. Now 6s2. Now this is most important element. Just see. Try to understand. Europium has got the half filled electronic configuration. That is 7. F7. Now Galiodium is the element of lanthanides which has got one electron in d orbital also, 5d1, because in all other cases their d electron have been shifted to the 4f orbital. Okay, 4f orbital, but here 5d electron has not been shifted, because if it would have been shifted then the symmetry of 4f orbital would have been disturbed, because it has already attained the stability having 7 electron, that is half filled state. Okay, so this is there. Now this is terbium. Terbium, what is this one? Just see, 7 directly it has reached to the 9, because one electron of this one 4f, because this is 64, now this is 65, so one electron will be added, so it would have been here 4f8, but one electron of this one has already been shifted. Now this is dysprosium. Let me check. D by means yes, dysprosium. This is 4f10. Holmium 4f11. Now erbium 4f12. Now this is terbium. What is this one? Let me check this one. Thulium, sorry. This is thulium. Thulium 4f13. Now just see. Ytterbium. YB means ytterbium 4f14, 5d0. now last one is the lutetium, that is 4F14 5D1. so now if you see carefully, there are two elements which have got electron in 5D orbital. One is gadolinium and another one is the lutetium. What is the reason? If 5D electron would have shifted here, the symmetry of the orbital would have been disturbed, stability of the orbital would have been disturbed, because lutetium has already got 14 electron fully filled. Okay, that is why I will write here 5D electron has not shifted to 4F because 4F has already completely filled. Okay, bracket F14 state. Similarly here also same thing, 5D electron has not been shifted to 4F because it has already attained half filled state. Okay, so just remember gadolinium and lutetium. Yes, gadolinium and lutetium. Okay, so electronic configuration is completely completed and duration of video has already been completed. So thank you, just you do this one and afterwards we'll begin the remaining trends in physical property. Okay, so let us concentrate more on the electronic configuration of lanthanides. It is easy to remember also. Thank you.